Hey, this is Dan with Weld Fever. On today's episode, we're going to take yet another fantastic viewer request. We're going to do a little stick welding on some light gauge material with some thin electrodes. So stick with me, here we go. Hey, before we start the show, real quick, I just wanted to remind everybody that the Weld Fever official logo hat is in and ready for sale. Pick yours up today. Doing so really helps us out here at the show, allows us to purchase more material, more electrodes, and make the show a little bit better. So show your support for the show if you would please. Pick up one of these Weld Fever official logo hats. Just go to www.weldfever.com and click the top store link and it'll take you right to the cap. In the future, we're going to have some t-shirts too. I'm working on some great designs, so look for those in the future as well. Anyway, keep stopping back at www.weldfever.com. We've got the store, we've got a forum, we've got a blog on there, and I've got drawings from some of my videos as well as links to the videos as well. So make sure to check on www.weldfever often. Okay, so what I have been asked to do today is to take some thin gauge material or some light gauge material and to weld it using some thin electrodes. Now, here is the material I'm going to be using today. This is considered light gauge material. It's 10 gauge, roughly around 10 gauge. To be more exact, it's 1/8 of an inch thick. That's 0.125 of an inch thick, or I believe it translates to roughly around 3 millimeters if I'm not mistaken. Anyhow, this is considered light gauge. It's on the heavy end of light gauge. Usually 1/8 is the maximum thickness that you would be allowed to still be considered light gauge or sheet metal. Anything usually beyond 1/8 of an inch is then considered plate steel. But anyhow, here's what we're going to be using today. The electrodes that we're going to be using are as follows. This is a 3/32 diameter 6011 electrode. Now, I don't know if you'll be able to see this very well, but here's a kind of a camera shot of both of these electrodes. You can see the diameter is measured not from the flux core over here, not from the flux coating, but actually from the bare end or the actual roundness of the filler material. This is where we're getting the diameter from. Now, keeping this in mind, check this one out here. We have a 1/16 diameter, this one's really hard to see, it's so small, 1/16 diameter 6013 electrode. Now take a look at this in comparison. Hopefully these camera shots will show you just the difference in thickness. This is the typical 1/8 that we use for just about everything. And then look how small these other ones are here in comparison. Really an interesting sight to look at. Okay, so I'm going to use this tiny little 6011 electrode. I'm going to throw the amperage up to about 60 amps. And let's see if we can't, I've got this kind of set up here for it's an ugly piece, I admit it, but I've got a good edge here for a nice T-joint. So I'll go ahead and see if I can't weld this thing up real quick. Here we go. Alright, so that went in relatively well. It felt good going in. I didn't feel any major problem. Let me clean it up and see how she looks. And there's a close-up of the bead. Went in pretty well. Let's move on. Okay, so now I'm going to use the 1/16 E6013 electrode. I'm using it at 40 amps. I'm just going to go ahead and run a quick bead on this because I have very few of these, and to be perfectly honest, I hate these rods. In fact, I don't even know why I'm demonstrating them on YouTube. I think they just trap slag way too easily. If you run a regular bead on them, they're fine, but the minute you try to do a T-joint or a lap joint or something like that, all of a sudden they become very, very problematic. But in either case, I said at the beginning of this video that I was going to go ahead and use these, and I will. So here we go. Another thing I hate about these things is just how quickly they burn, particularly when you get down to the end. It's like all of a sudden they seem to go into overdrive. So I'm sorry, but I'm just not a fan of this rod. Let me clean this up and see what it looks like. Okay, there it is. You know, it looks okay because of the oscillation and has a nice ripple pattern, but I will stress that this is not designated an oscillating rod. So the fact that I did that is probably a bad thing. I'll go ahead and strike one next to it now, just for the sake of doing it, for the sake of argument. That is not oscillated. I'll just go ahead and strike one, and I'll run a quick bead that is not oscillated. I'll run it right next to this one, and hopefully it'll come out okay. Here we go. Okay, so for this one I did a little slight side-to-side movement. Once again, the slag on this is incredibly thick, but let me clean it off real quick. Okay, here's a little closer up shot of those beads that I did with the 6013 rod. Now you're going to notice that these things, they look gigantic, but in reality they're like very small. They're less than 1/8 of an inch across, which would be somewhere around 3 millimeters for you metric folks out there. These look very similar, even though one was just a side-to-side motion and the other one was kind of a circular oscillation that I did. And you're going to notice they kind of stick up proud of the plate quite a bit. Well, the reason for that is because this is a 6013 rod. And a 6013 rod is a medium penetration at best rod. And the reason for that is because, as I may have explained earlier, a 6013 rod's original purpose, the reason why it was created, was to be a sheet metal rod. Nowadays there are, you know, like I think I might have mentioned this earlier, but nowadays there are bigger versions of 6013s. They make them in the 1/8 inch and probably larger. But anyhow, that's why it's sitting proud of the plate and not penetrating more. Okay, so that's that. Okay, so now I'm going to do a little lap joint here with a 6011 rod. And this is a simple joint, pretty much. Not much to it. First, let me tack these down. These are like scrap pieces. I think I explained that earlier, but let me tack these into place and then I'll go ahead and perform this weld. Okay, in case you've forgotten, this is a 3/32 E6011 rod, electrode, and I'm using it, I'm going to be running it at 65 amps here for this joint. This plate that we're using is 1/8 inch thick, and it is ready to go. Here we go. Alrighty then, as you might have noticed, that was a pretty tough one there. It was a very intense. Probably my amperage was a little high. I'm going to back it down here to about 55, and we'll see how it looks. If it looks like it was too hot, I'll run it again. Well, believe it or not, despite it seeming to be incredibly hot and maybe like too hot, it actually went in pretty good. It's good penetration, good fusion. I don't see any noticeable problems, and it was able to cover this lap joint nicely. Covered over the rounded over the top, and fuse into the bottom here without any undercut. So I still got some slag that I need to clean out a little bit better here. I don't know if you can see it on camera, but all in all, not a bad little joint. Okay, now we're going to be producing the granddaddy of all thin gauge or sheet metal welds, and that's the butt weld. It's probably the most difficult one to produce because not only do you have to produce a nice bead on the top here, but around the back side you want to have good penetration as well. And if you don't have it, then you don't have a decent butt weld, plain and simple. So this is probably the most difficult thing to master when it comes to butt weld, is actually getting that penetration on the back side. I'm going to go ahead and run this. This is 1/8 inch thick material. This is a 3/32 E6011 electrode here, and I'm running this at 60 amps. So we'll see if that has enough punch to get through this thing. Wish me luck. Well, I have to say that went in pretty well. Now we can only hope that we have the proper penetration on the back side. Well, from the top side here, I'm very pleased with the quality of the weld bead. Let me bring this up so you can take a look at it. Yeah, the weld bead quality is good. It's slightly convex, which means it's sticking out from the plate a bit. The weld ripples are even. Hopefully you can catch this on the light. We got an even ripple pattern here, and the width of the bead is uniform throughout. Now, let's see what we got on the back side, because this is where it all counts. Drum roll, please. Ah, look at that. Looks like we've got penetration all the way through here. It's like right exactly to the edge here. Maybe like a millimeter below it, but I would say that's acceptable. Okay, that's it for this one. I hope you guys enjoyed this episode. I know I did. Anyhow, don't forget to join us on our next one, and visit www.weldfever.com. Don't forget to support the show by buying one of our hats, and we'll see you on the next one. Thanks a lot. Bye-bye.